Hello, good morning, dear friends, my dear students. Once again, I am here, Lalit Kumar P. Bhaiya, Associate Professor, Electronics and Telecommunication Engineering Department, Bharati College of Engineering and Technology, Durg. This is my 44th video on the topics of your syllabus of Applied Electronics and Instrumentation. Dear friends, till now we have discussed about the measurement of the pressure, various sensors used for the measurement of pressure and instruments used for the measurement of the pressure. And we have seen how the pressure can be measured with these sensors and instruments. Today we will discuss about one of the most important topic of the instrumentation of your syllabus, that is strain gauges. Let us move ahead and see these strain gauges. What is strain? This is the question. Then and only then we can understand the strain gauges. Strain is the amount of deformation of a body due to an applied force. More specifically, strain is defined as the fractional change in length. So, how you can define this strain? Strain is nothing but a fractional change in length. Basically, we define in terms of delta L by L like this. Strain is the amount of deformation of a body due to the applied force. When we apply the force to a body, there may be a change in the length. Then we can determine the strain. That change in length is called as the strain. Strain can be positive, that is tensile, or can be negative, that is compressive. So these are basically two types of strains. Either it is tensile form, positive form, or it is negative, compressive form. That is, you can say length is increased or length can be reduced like this. Although it is a dimensionless, strain is sometimes expressed in units such as mm per mm, because it is change in length upon length. So it is dimensionless, but sometimes it can be in terms of mm by mm. In practice, the magnitude of measured strain is very small. Therefore, strain is often expressed as microstrain, mu epsilon, which is epsilon into micro 10 to the power minus 6. 10 to the power minus 6. Here you can see this epsilon, that is strain, is given by del L upon L, change in length upon total length. It's called as a strain, where epsilon is the strain and delta L is the extension or contraction. Either it may be increase in length or it may be a decrease in length, and L is the original length. When a bar is strained with a uniaxial force, a phenomenon known as Poisson strain causes the cross section of the bar to contract in the transverse or perpendicular direction. The magnitude of this transverse contraction is a material property indicated by its Poisson's ratio. So you try to understand this strain is related with this Poisson's ratio. which is a very useful term in instrumentation also. So when a bar is strained with a uniaxial force, a phenomenon known as Poisson strain causes the cross section of the bar to contract in the transverse or perpendicular direction. The magnitude of this transverse contraction is material property indicated by its Poisson's ratio. So this is the fact about the strain. Now strain gauge measuring principle. Strain gauge is the gauge which is used to measure the strain. So strain gauge measuring principle, let us see. The basic techniques for strain gauge measurement involves attaching, gluing a metal wire or foil to the element whose strain is to be measured. So what we do in basic technique, strain gauge measurement, which involves the attaching a metal wire or foil to the element whose strain is to be measured. As stress is applied and the element deforms, the strain gauge material experiences the same deformation. If it is securely attached, because strain is a fractional change in length, the change in strain gauge resistance reflects the strain of both the gauge and the element to which it is secured. So when force is applied, there is a deformation of a material. That is, there is a strain, and then strain is converted into the change in resistance, strain gauge resistance. That resistance reflects the strain of both the gauge and the element to which it is secured. Strain gauge material. Strain gauges are made of materials that exhibit significant resistance change when strained. This change is the sum of three effects. First, when the length of the conductor is changed, it undergoes a resistance change approximately proportional to the change in length. Second, in accordance with the Poisson effect, a change in length of a conductor causes a change in its cross-sectional area, and a resistance change that is reverse proportional to the change in area. So this is the material, strain gauge material. Then what is stress? In general, the stress is expressed as sigma is equal to F upon A, where sigma is the average stress, also called as engineering or nominal stress. F is the force acting over the area A. This is the formula for the stress. And what is the strain formula? The strain is defined as the fractional change in length. That is strain. Either you can write epsilon or G here is equal to delta L upon L. Delta L is the current length and L is the original length. Strain is thus unitless quantity, and the relation between stress and strain is strain is equal to stress upon Young's modulus of elasticity. Material is the module where every material is the modulus of elasticity E, and this E is given by strain upon stress. Stress upon strain. That is sigma upon this epsilon. Just a minute, please. So this is about the strain. this modulus of elasticity, E is equal to stress upon strain, sigma upon epsilon. This part also comes that while studying this modulus of elasticity. Strain gauges. Strain gauges senses strain produced by the force on the wires and converts that into a change in resistance. Strain gauges senses the strain produced by the force on the wire and converts that into the change in resistance. So force is applied, that is, the strain is applied to the wire or on the wire, that will produce the change in, that is, the deformation is there, and that will convert it into change in resistance. If a metal conductor is stretched or compressed, its resistance changes on account of the fact that both the length and diameter of the conductor changes. Once you put the weight on a particular wire, there may be a change in length of the wire or its diameter also. Also, there is a change in the resistivity value of the conductor when subjected to strain. A property is called as piezoresistive effect. Also, there is a change in the resistivity value of the conductor when subjected to strain. A property called as piezoresistive effect. Strain gauge is also called as piezoresistive gauges. Strain gauge is also called as piezoresistive gauges. When a gauge is subjected to a positive stress, its length increases while its area of cross section decreases. When a gauge is subjected to a positive stress, its length increases while its area of cross section decreases. Since the resistance of conductor is directly proportional to its length and inversely proportional to its area as per the Ohm's law and formula we have seen, not Ohm's law, resistive formula of the resistivity. Since the resistance of conductor is directly proportional to its length and inversely proportional to its area of cross section, the resistance of the gauge increases with positive strain. This is important. The change in resistance value of a conductor under strain is more than for an increase in resistance due to its dimensional changes. This property is called as piezoresistive effect. To try to understand what is this piezoresistive effect, the change in resistance value of a conductor under strain is more than for an increase in resistance due to its dimensional changes. Then this property is called as piezoresistive property or piezoresistive effect. From the equation of resistance, just I have told you here, since the resistance of a conductor is directly proportional to its length and inversely proportional to its cross-sectional area. So you can see R is equal to rho L by A, where this R resistance is proportional to its resistivity and length and inversely proportional to area. R is the resistance, rho is the specific resistance of the conductor material called as the resistivity. L is the length of the conductor in meters and A is the area of the conductor in square meter. This is the diagram for the strain gauges. This is the foil type shape you can see, and these are the two wires where resistance is to be measured. Force is applied on this particular foil, then its length will change and accordingly its resistance will change, and that will be observed in this wire. This is the another diagram. This is the supporting base and these are the two leads. And here you can apply the direct strain. This is the direction of the strain to be applied. When a strain is produced by a force is applied on the wires, its length increases and area decreases. This is the structure of the strain gauge, where length increases and area decreases. From the equation of resistance, you know R is equal to rho L by A. So length increases and area decreases. That means resistivity increases. Resistance increases. Length increases, area decreases means this resistance increases. And as resistance increases, then we can write the gauge factor. K is equal to delta R upon delta L upon L. This is called as gauge factor. K is called as the gauge factor, where R is the initial resistance in ohms without strain, and delta R is the change in the initial resistor in ohms. L is the initial length in meters without strain, and delta L is the change in initial length in meters. So this is the gauge factor of a strain gauge, which is equal to K, or somewhere it may be written as G, delta R upon R and delta upon delta L upon L. Change in resistance to the change in resistance to the original resistance upon change in length to the original length. Strain gauge, the gauge factor, this we have seen. But here one thing is to be remembered. This delta L upon L is also called as the strain. In gauge factor, this is also called as a strain. So delta L upon L is strain. So you can write K is equal to delta R upon R. Strain is written as in terms of G. G is the strain shown here. Somewhere epsilon may be the strain shown. So K is equal to delta R upon R into G is the formula for the strain gauge, where J is the strain. This is a strain gauge factor. Remember, for a strained thin wire, this is shown here, and this is the diameter, while this is the length of the wire. Then delta R by R is equal to delta L by L minus delta A by A plus delta rho by rho. And A is the area, that is equal to pi into D by 2 whole square, where D is the diameter for circular wire. So this upper part is shown for the circular wire. And then Poisson's ratio, it relates the change in diameter D to the change in length. Poisson ratio mu, it stands in terms of the mu, relates the change in the diameter D to the change in length. And this delta D by D is equal to minus mu into delta L by L. Delta D by D is the change in diameter upon original diameter, is equal to minus mu. Mu is the Poisson's ratio, and delta L is the change in length upon original length. Thus, we can write this equation in terms of this Poisson's ratio. Delta R by R is equal to 1 plus 2 mu into delta L upon L plus delta rho by rho. This is the dimensional effect, and this is called as piezoresistive effect. Delta rho by rho is the piezoresistive effect, and this is called as dimensional effect in terms of Poisson's ratio. So you can write this formula also. And gauge factor, K is used to compare strain gate materials. K is equal to delta R by R upon delta L by L is equal to 1 plus 2 mu plus this delta rho by rho upon delta L by L. This can be modified, and written here in terms of gauge factor K. So gauge factor K in terms of the Poisson's ratio, and resistivity and length, where K is equal to 1 plus 2 mu. If you neglect this piezoresistive effect, then K is equal to 1 plus 2 mu. K is equal to 1 plus 2 mu. K is the gauge factor and mu is the Poisson's ratio. Right? So these are the small derivations and formulae related with the gauge factor, Poisson's ratio, change in resistance and change in length and diameter. Okay. Then this is all about the what is strain, what is Poisson's ratio, what are the formulae for the strains, and we have also seen the strain gauge for the measurement, diagram of it file also. Then we will go for the types of strain gauges: wire strain gauges, resistive wire, bonded wire and unbonded wire, rosette type, torque type, helical type, foil strain gauges, semiconductor strain gauges, etc. So these are the various types of the strain gauges. So wire strain gauges, in which resistance wire is there, and this resistance wire is of two types: bonded wire and unbonded wire. Then rosette type, torque type, helical type strain gauges are there. As earlier I have shown the diagram, foil strain gauges are there, semiconductor strain gauges are there. On the basis of the formula, we have this type of problems. A resistance strain gauge with a gauge factor of 2 is fastened to a steel member which is subjected to a strain of 1 into 10 raised to minus 6. If the original resistance value of the gauge is 130 ohm, calculate the change in resistance. Very simple. You can use this formula, gauge factor. K is equal to delta R upon R into delta L by L. That is delta R upon R into G. G is called as a strain. And from this you can calculate value of delta R. This type of numericals are also there. A resistance wire strain gauge uses a soft iron wire of small diameter. The gauge factor is plus 4.2. Neglecting the piezoresistive effects, calculate the Poisson's ratio. As per the previous formula, we have seen this formula 1 plus 2 mu, and from this you can calculate this value also. This is another problem. You go through this type of problem also by observing this video and try to solve it. This is another problem I have taken: strain, change in resistance and the output voltage which is to be calculated. If you do it, it's okay. Otherwise, you just go for the theoretical part properly for the strain gauges. So this is all about the strain gauges. Thank you very much. In next video, we will go for the another topic, that is measurement of force. So later on we will see the measurement of force as per your syllabus. So dear friends, go through the details of the strain gauge. If you have any doubt, any difficulty, ask me at any time on any platform. You can also ask on your classroom. Thank you very much. Thanks a lot.